Firstly, we open up www.circuitlab.com. Then we launch the editor. Then we open. And to get this, you need to have set up an account. Okay, we'll open this in the editor. This is a 555 timer circuit that I took out of their library. The way this works is that at the input here, whenever there's a negative going trigger, then what will happen is that here at the output you will get a pulse that's dependent on the RC network over here. This is best seen with a timing diagram, and to see the timing diagram we will push simulate, and here at the start is 0 seconds, the stop time is 3 seconds. We've got 0.01 second steps, so we'll run the simulation, and here's our timing diagram. Alright, here's the square wave input going into the 555 timer, get a negative going edge on the square wave, and this in turn causes the output to go high. It'll go to 5 volts. Right? It stays at 5 volts until the RC network reaches 2/3 of 5 volts. At that particular point, we get the RC network is discharged, and the circuit waits once again for a negative falling edge. Okay, going back to our circuit, we can see the negative going trigger occurs here with our square wave. As soon as this edge goes low, goes from 5 volts, heads towards 0 volts, well, this point here is allowed to charge up, and the RC is charged up off the 5 volt rail here. So current flows through the resistor into the capacitor, and the capacitor charges up. Okay, this occurs in response to a falling negative edge here. And as soon as that negative edge occurs, the output goes to 5 volts. Just to reinforce what's going on here, so there's our input. It's only a 2 volt square wave here, but that's fine. It could be a 5 volt one if we wanted it to, but the main thing is we get a negative falling edge here, followed by a rising capacitance voltage being charged up through the resistor, so you've got this exponential curve. As soon as you get this negative edge, we then get a rising edge or a rising output, and this output could be used to drive a relay, an LED, something to switch something on, and we can determine how long this output stays on by this RC value. Okay, back here we could delete this and just replace it with a resistor, and we could say get an LDR photoresistor, LDR, put it in here, and as a result, when there's a lot of light on the LDR, you'll get a very low resistance. So for example, if I covered my finger over the LDR, the resistance would go up. This would mean this voltage would drop, and therefore you would get a trigger pulse, which would then give you an output of 5 volts for a time determined by this RC network. Hence you could have a light triggered device, or you could replace the LDR with a photo transistor,